Hello viewers, welcome back to our Digital Seekers channel. Today we are going to talk about Docker. So we'll learn about Docker and then how it works. Basically, before even starting with the Docker and all of this, let me just share a small story with you. So when I was in my plus 2, I used to feel difficulty understanding physics. One of my best friends actually suggested me or helped me in learning concepts of physics. The way he told me was, you have to visualize, you have to conceptualize, you have to actually see things, what you're learning. That means you have to actually visualize those things in your mind so that you can really understand how it works. So initially I felt a bit difficult. He helped me around various concepts in our physics in plus 2. Later I started finding it easy whenever I learn a new thing, any new thing related to science and technology. Coming back to Docker, many of you would have already are familiar with Docker or you have been using Docker. Before getting into Docker as a technology to learn what it is, how it works, so there are some prerequisites. So one is you should already know what is virtualization, how it works. And if you are a seasoned developer and then you already have spent some time in developing various projects in across various languages, then you might have already heard about virtualization as a technology, how it has progressed over a period of time and what it really meant. If you don't know about virtualization, don't worry. I have another video which is talking about virtualization, how it started and what it is right now. And you can go through that video and understand what is virtualization. Hope you have already gone through the video of virtualization or you have already enough understanding of what virtualization is. Let us briefly touch upon virtualization and then move on to our actual topic, Docker. So virtualization is the concept of sharing the hardware resources like hard disk, RAM and processing cycles with any computing program. So a computing program is performing a specific given task or action, right? Okay. So now we understood what is virtualization at a high level. It is okay that even if you don't understand in depth. And let us quickly get into the Docker. So as you learn any other technology, if you are a seasoned developer or a newbie, in both the cases what you generally learn doing is the hello world, right? So you would have done this hello world in all the technologies that you have learned so far. That is a typical way that you start learning any particular technology or any particular language for that matter. When it comes to Docker, so you would have been stunned because you would have executed some sequence of commands to install Docker on your machine, on your operating system, and finally you would have run one single command to run the hello world. But when you have done hello world in any other programming language or any other technology, you would have done at least some amount of work. But here in Docker, you hardly did anything, right? So to understand what actually has happened behind the scenes and what Docker has done, so when you have run the Docker hello world, it would have done some download multiple layers, and then it would have done pull and then extraction, and then it will actually execute. Okay, but when you run it again, it doesn't do any of that, right? It simply executes. So what is happening? So what exactly is happening behind the scenes in Docker or Docker world, and how is it maintaining those layers and whatnot, right? So this is something which is interesting to learn about. Now, we'll park it aside, and then we'll actually learn how this concept actually brought into place. To start understanding this concept, let me give you a smart obedient kid, and let me tell you what this smart obedient kid does and what he's good at. So these are some traits of this smart obedient kid. So he does exactly what we ask him to do without asking any question, and he keeps track of what he has been doing. That means he maintains a ledger or an index of what he has been doing. And then he performs the tasks one at a time. He doesn't just go and then do everything at once. He just does one task at a time. He's not a multitasker, for the matter of fact. and then does the tasks in the order given. So he is not jumbled up. I mean, like he doesn't do the first thing and then the last thing and then the middle one. So he doesn't do that. He actually does that in the sequence that you have given him the tasks. So these are the 4 important traits of the smart kid. And it is tempting. I mean, like when you look at these traits, I mean, it is tempting that you might want your biological kid actually to do like this. I mean, believe me, it is not going to happen. Kids are much more smarter. They actually do what we ask them not to do, and to do anything that we ask them to do, they'll ask tons of questions. They'll find creative reasons to not to do that work rather than doing that, right? So this is the tendency. So I mean, like the first trait itself is gone, so forget about the rest of them, right? So don't try with the biological kids. It is actually, I'm giving you a fictitious obedient smart kid, and this smart kid actually does these 4 things and does them well, right? So now we have this obedient smart kid, and let us give him some instructions, right? So what kind of instructions we are going to give him? Let us give him instructions to build a clock, right? So interesting. It should be a bit interesting, right? So now what we'll ask him is we'll actually give him instructions for a clock. So what are these instructions? So the first one says draw a circle with 12 equal distance notches. Okay, interesting. Circle with 12 equal distance notches. And draw numbers 3, 6, 9, 12 at 0, -90, 180 and 90 degrees. Okay, a bit complex. But he's a smart kid, you remember. So draw hours, minutes, seconds hand at 0, 90 and -90 degrees. Okay, I don't know what it means. Let us see. He's a smart kid, he'll do it, don't worry. So draw a brand logo Ajanta above 6. Okay, so he has some set of instructions. So let us say we gave him some block of glasses, so which are same size glasses. So I actually got them for illustrating this example. So let us say we gave him the first task, which is actually draw circle with 12 equal distance notches. And let us say he came up with this. So he draw a circle and he draw 12 equal distance notches. Good. And then the second one is he's actually stacking up, right? I mean, he is performing the actions one after the other and he's stacking them up. So the second one says draw numbers 3, 6, 9 and 12 at 0, -90, 180 and 90 degrees. Okay, this is a bit complex. So he took another slate of glass and then he draws 3 at 0 degrees, 6 at -90 degrees, he's going down, and 9 at 180 degrees, he went like this, 9 at 180 degrees, and then he has 12 at 90 degrees. So he draws these 4 numbers and he's stacking it on top of his previous one. Oh, we are already seeing something interesting, right? Okay, so what is the next one? Draw hours, minutes, seconds hand at 0, 90 and -90 degrees. Okay, so now we are asking him to draw hours, minutes and seconds hand. So this is what he has done at 0, 90 and -90 degrees. So let us stack it on top of our previous glass and then see what happens. Oh, okay, interesting. So now we have a clock which is showing 3 o'clock 30 seconds. Okay, interesting. And finally we asked him to draw a brand logo Ajanta above 6. Okay, he has drawn a brand logo Ajanta just above 6. Okay. So finally, when you look at these stack of glasses, what you're seeing is a clock. I don't know whether you're able to make it out from the glasses, right? So this is actually a clock that he has built using the sequence of instructions we gave him. So what we have done, we have asked him to perform some sequence of action, sequence of tasks, and he did it exactly the way they are given with. And this is how even your Docker works. So you give it instructions one after the other, and it actually performs those instructions one after the other, stacks them up one top of the other, each layer on top of the layer, right? So finally it comes up with an image. This is not running, okay? So this is just a clock, this is an image. So you already told him what he has to do at various places and he has performed it. There is no machine behind it and there is no power given to it. So unless you put a machine and a power behind it, it is not going to work, right? So the same way, I mean, like when you create a Docker image, you give a set of instructions 1, 2, 3, 4, 5, 6, and it actually performs those instructions. Each instruction is written on a layer. Now you can consider that layer is opaque, and then, I mean, like, it is, once it is written, it is not opaque, it is, once it is written, it is written in stone. I mean, like, though it is etched in the glass in our case, right? Because we cannot say stone because we have used glass, and then it has to be transparent. You should be seeing what is happening behind the what is happening in the previous layer. So for that you have to consider them as stacked glasses etched. So what he has done right now, I mean, I draw it using a marker, but assume that they are all etched on glass. So if they are etched on glass, then you will see, I mean, it will never change. That piece of glass will remain with that particular information forever. So similarly, when you give Docker these instructions, what it will do? It will etch those instructions, or it will etch whatever is the output of that particular command onto a glass frame, and then it stores it. And it stacks with the next one. So it will perform the next level of next command, and then it will actually etch it into the next glass, and then stores it on top of the other. So just like we have done in our clock example. So where we have created a circle with notches, and then we added numbers on top of it, and then we added our clock hands, and finally we branded it, right? So this is how even Docker works. I mean, like, as I said, you give it a sequence of commands. Each command is actually written into one layer, and then that layer has a name, or if you have given it a name, you can actually give it a name. Otherwise, it will actually keep a random unique ID, and then it will maintain that layer with that command. Just like our smart kid, what he does, he actually keeps track of what he has been doing. So he knows what he has done in each layer. I mean, like, what command he has executed and what is the output. So he remembers it, and he has a link to it, right? A name to it, an index to it. Now, so we are done with building a clock. So why not we ask him to do some advanced task? So let us give him some advanced instructions for the clock. So what we have done is, again, I mean, I reduced the length of the lines so that you can read it quickly. So we ask him to draw the circle with notches, draw the numbers 3, 6, 9 and 12, draw hours, minutes, seconds, hand. So this is exactly what he has done earlier, right? So he remembers what he has done. You remember that? So when you ask him the same instructions again, he is not going to perform it. He's a smart kid, you know. So he is just going to pick the layer. So what? He just go on, then the moment he sees these instructions, he knows it. He has to draw a circle with notches, and he knows that it is never going to erase, right? So he simply picks that layer. He doesn't build it. He simply picks that layer. He is not going to etch it again. And now the second thing is draw numbers 3, 6, 9 and 12. Well and good. So he just need to draw numbers 3, 6, 9 and 12, and he knows what he is doing, right? And he has done it earlier as well on top of a circle itself, right? So he knows he has done that on top of a circle, and he has drawn 3, 6, 9 and 12. So he's just going to pick the second layer. He is not doing anything different. So now he draws hours, minutes and second hand. So now, I mean, if you have changed your angles or anything, he is going to draw a separate layer, or otherwise he is going to pick the same layer as we have done it earlier. Like if you have given it as 0, 90 and minus 90, he is going to pick the previous layer, and then he is going to draw a 3 o'clock clock, right? So he achieved this. For this, he did not do any work, any hard work. He is a smart kid, remember? So what he has done, he has picked all the 3 layers which he has already created because he knew it. So what he has done, the final instruction is call this as clock base. Now, after doing all of this, he is just naming this stack. So naming this stack as a clock base. Okay, well and good, he named it. He's a smart kid, he knows it how to name it. So he keeps it somewhere else, some other ledger. And then we're actually saying that is done. So he stacked it and kept it aside. Now there is another set of instructions. This set of instructions are over. Now another set of instructions. What we are asking him to do now? From clock base. Oh, okay. So he doesn't need to worry. I mean, like he know what he has to do from clock base. I have to pick clock base. So what is clock base? Remember, he named it. He know it. So he picked the clock base directly, without a doubt. He know what he has to do. And then he is saying that draw brand logo Ajanta. So he simply picks up another layer because he knows on top of these three layers only he wrote Ajanta. He simply picks that layer and he presents you with the clock for Ajanta. Instructions are complete. He did not do any work. So he created another branded clock. I mean the exact same branded clock, but he has done it in a different way. I mean, like he has a clock base in between. Now let us ask him to actually create another branded clock, Titan. So we want to build a clock Titan. So what if we are asking from clock base? So that means he has to take the previous stack, which is having a circle, numbers and hours and minutes and seconds and. Now he has to draw a brand logo Titan. So what he will do is he is going to take a brand new slate. Why? Because his previous slate already has Ajanta. So that has no meaning. So the instruction is different now. He has to write what? Titan. And now what he is going to do? He is going to stack it on top of your previous glasses. And now he has a Titan clock. Now he has reused the previous stack and he simply created another layer which is just having the brand name Titan. So this is exactly how Docker works. So it keeps remembering what it has been doing for each layer along with the command it has executed. That means you have asked it to draw a circle with notches. Okay, it remembers equal notches, 12 notches. I mean, if the command is exactly the same, then it remembers it. Good. So what is the next one? Okay, so next one is drawing numbers at 3, 6, 9 and 12. Okay, well and good. So it knows how to write 3, 6, 9 and 12 and it also remembers it is doing on top of the previous glass, right? Every time it has the name of the glass that it is creating, a unique ID, and the command that it is using and on which base layer it is actually writing that new layer. So it always keeps track of these three informations. One is what is the command, and second one is on top of which base it is executing this command, and third one is what is the unique ID of this. So now once it remembers all of this, what it has to do, anytime a new instruction comes, it has to check what instruction it is and then on which base I am executing this instruction. So as soon as I know it, I can either pick it or I can execute it. So this is how it is actually going to create your images. Okay, so far we have asked our smart kid to create a clock, and then we asked him to actually, after creating a base clock, we asked him to name it as base clock, and then we asked him to create two separate images, by one for Ajanta and one for Titan. That means using the same base class he is able to create an Ajanta clock and he is able to create a Titan clock. Now sometimes it is not sufficient because you might want to change something which is already existing in the previous layer, right? And as you all know that the previous layer is etched in glass, so it cannot change. You cannot go and then erase it and then write something new there. So what you can do, you can replace it with something else. How you do that is you simply overwrite that place in the disk with a different thing, right? So now let us give him an instruction for replacing content in our clock, right? So these are simply two instructions that we are giving him. From clock base, he is going to pick the clock base stack, he already has named it, and then he is going to execute this additional command. And here if you see, our kid is smart, right? So he can actually perform multiple operations at once in one layer. That is what we are doing here. So create a brand logo Ajanta and replace the notches with squares. So Ajanta brand actually wants to create a clock with squares now. Earlier they have the earlier notches, and Titan also came with the same notches clock, so they wanted to be different in the market. So for that they wanted squares. Yeah, I mean visually they are different, right? I mean like when a notches clock and a squares clock, they are different. And Ajanta doesn't want to actually reinvent the wheel in creating another base clock because they have already invested in the base clock. So what it does, it is actually taking the base clock and it is asking the smart kid to create a brand logo Ajanta and replace the notches with squares. So if they have named their clock Ajanta as an Ajanta clock, they could have simply asked from Ajanta and then they would have asked to replace to just create the notches or squares. So now, I don't know whether you are able to see it clearly. Now the Ajanta clock is there and the notches are replaced with squares. So this is how exactly your Docker works. It will actually perform the actions as we said in the right way. And let us assume you have a file by name abc.txt in a specific path in your first layer. So now we are coming to the layers in Docker, how it does. And you have another layer in which you actually removed it. That means in that path there is no abc.txt. Now, when you stack these layers, how Docker will know whether there is a file or there is no file? Because at a ground level layer, there is that abc.txt, but in the upper layer, you remove it. So now it just remembers what is it is seeing from the top. So the information on the top supersedes the information on the bottom. And you can still look to the base clock. So in this case, when you look to the base clock, you will still see the notches. So they are not changed because as we see from the base clock, it still has the notches. That means that file abc.txt, if you assume that notches or straight lines that we have seen with the red color are actually that abc.txt, then at the same place we have created squares, or we would have completely wiped it. That means there are no notches at all. It is possible. So this is how Docker works. So all it does is actually creates a layer on top of the layer, and each layer has an entire file system paths maintained in a ledger. So it will maintain that ledger for each layer. So now when a new layer comes in the same ledger, it is actually wiping that particular abc.txt. That means even if it is present in underneath file system, it is not going to pick it. You have to just assume as a stacked classes, each layer is getting created, and these classes are actually in a way creating an image, the Docker image that we call, right? After taking the video, what I observed is you are not able to see the glass content from a distance. That is why I'm showing it from the close. So this is the circle the kid has drawn with notches. So you can see 12 notches on there. And then we are actually having another layer which is having these numbers on top. Now we are actually stacking it on one top of the other. Now you can see the numbers coming right at 0 degrees, minus 90 degrees, 180 degrees and 90 degrees, 3, 6, 9 and 12. And then we asked him to draw the minutes, seconds and hours hand. So you can actually see that. So hours hand at 0 degrees, minutes hand at 90 degrees, seconds hand at minus 90 degrees. When you stack it on top of your regular previously built stack, so then it is actually coming like this. So this is what you can see as a clock, right? The word Ajanta, and which is written on top of the clock, base clock, and this is how the final clock looks like. Okay, so you can actually see the Ajanta clock, and if you see it from the side, these are actually stacked layers. So these layers translate into your image. So finally what you see is an image of a clock. So with the help of our smart kit, we are able to create images, a base image, and then extend that base image and then create other images for various brands, one for Ajanta and one for Titan. And then we also created another version of Ajanta by replacing the notches with squares, right? So we have learned how the smart kit is doing his set of tasks and stacking them up and creating names for those images. So similarly, Docker also does the similar work. So to ask Docker to perform our sequence of actions, we'll write a Docker file. So just like we have done it in our notepad, we actually need to write some sequence of actions. So the first one, the very first action should be a base class. So you have to write a base image. So which base image you are going to use? From Ubuntu 14.04 or Ubuntu 15 or CentOS, or I mean, like, you use any of these base images, or you can use another image that you have created, just like we have done it for our Ajanta clock from clock base, right? So if you have another image which you have created earlier, you can as well use that as your base image. So once your base image is defined by using that from clause, so after that you'll actually write sequence of commands. So each command, each line is going to be, each line, or you can write multi-line commands as well by using a backslash at the end in a Docker file. So you write these commands to create one layer. That means each command is going to create one layer. So what about the base layer? Is it one layer or multiple layers? It depends, right? So if you have used a plain vanilla, one single kernel, and even there it can be multiple layers. I mean, like, however the base image is created, so those many number of layers it is going to come with, right? And if you are using an existing image that you have created, that will have all the layers of that particular image as well as its base image, right? So it will have that many stacked layers. So now, I mean, like, when you have written your from statement, and then the next one is actually your command, as I said earlier. So that command is going to be a run command or an environment command or a command itself or expose. So there are various I mean, like, commands that you can run in this Docker file that are known to this smart kit, Docker smart kit, right? So that commands can be nested. That means you can say run and then you can write multiple commands at once. So you might want to write apt-get update and then apt-get install and a specific package, and then you want to install something else. You can actually stack all of them together and create one single command, one single executable command. So now that executable command will create one layer. So it is advisable to have multiple commands put together in one single executable command, is primarily because you don't want to create more layers. I mean, like, unless you really want to have a real meaning for that layer, you better not create that as a separate layer. So that is a matter of fact, right? So if you're not going to name it and then use it as a separate layer, so you better not create it as a separate layer. And if it is a logical conclusion, then you can actually bring it to a logical conclusion and then create that whole stuff as one single layer, which is good. And there are some caveats to it. I mean, if one command fails in the whole bunch of commands that you have written, the entire command gets re-executed. So that is when you might want to break it down into multiple chunks and then create separate commands for each executable one and then create them as separate layers, because each executable command in Docker file is going to create a separate layer. That is why it is going to execute line number 1, line number 2, line number 3, line number 4, so on, right? And then finally, I mean, like, once all these commands are executed, they are actually stacked up as one top of the other. And when you are running this Docker build command, you are actually going to provide a tag. Hyphen tag is equal to something. I mean, like, the tag is nothing but the name. Just like in our base clock example, we instructed the smart kit after 3 layers, we asked him to create a tag, a name, right? Similarly, we will instruct the Docker to create a tag by using that command. In the Docker build itself, you will say tag is equal to something. So you can name it and you can version it as well. The name, I mean, the naming convention for tag is outlined very in detail in Docker documentation. I don't want to go over it. So you can basically give a name to your image. So now that we have created images, okay, so these images are actually created and stored in your Docker varlib Docker in case of your Ubuntu, right, or Linux based systems. It is going to be slash var slash lib slash docker. I mean, is where all your Docker specific files and images or volumes are going to be stored. So let us not talk about volumes right now in the first session. So let us just talk about images. So we have these images there. Now, there is another concept for these images actually. I mean, like many of you might be familiar with these object oriented principles, like you can actually inherit and then you can do whatever, right? So here a high level inheritance is there, like you actually inherit from a base class, from base. So when base class, I mean base image, from base, that means you're actually taking the entire base image as is and then you're extending it. So you can extend any image that you have created and then you can perform any actions that you want to do. Just like in a regular classical inheritance that we all know. So if you want to have, I mean, like whatever public methods available in your parent class are available even through the child image unless the child image modifies it. Here the rules are actually a bit different, I mean, because it is actually a file system that we are dealing with, not really class function definitions and stuff like that. So it is a file system we are dealing with. If you want that file to be read only, read write, so you can do all those modifications, not just erasing files or replacing the files with something else, files and folders with something else. You can as well change the access permissions. So whatever is defined on the topmost layer, because whatever you see from the topmost layer is the final definition of your image. So that is what your Docker image is going to contain. That is what your Docker image is going to have, like those many files and then those access levels. So seekers, in this episode we have learned so far about one aspect of Docker, that is creating a Docker image. We have learned it with an analogy of a smart kid and using some glasses, and then how do you actually visualize these layers and how actually Docker writes those layers in the real file system. So with this we are going to wind up this session, and we are going to come back on the next session wherein we are going to talk about the runtime containers, how you actually use these images and create containers and run them, and how do you assign volumes to it. So we will talk about those those additional concepts in the subsequent session. To learn these sessions, please don't forget to subscribe and you'll get notifications as soon as I'm going to publish my next video. And please let me know what you think, and was this useful, and what else I need to elaborate more upon. Please give your comments. Thank you very much. Until next time, bye bye.